So this is off the torque problem worksheet. Number 1, we have a flagpole that's 25 meters high, so let's label that. The height of this pole, we're told, is 25 meters. And this angle in here is 15 degrees. So I'm going to erase that theta. Let's just put in here what it is. They tell us in the problem that the rope, there's a rope pulling on the flagpole, and it makes a 15-degree angle between the rope and the pole. And then we're also told that this tension is 500 newtons. So what we're asked to solve for is the resulting torque on the flagpole. Now look, what is torque in the first place? Torque is the ability of a force to rotate an object. If you pulled on a flagpole like this, if you pulled hard enough, could you make this flagpole topple over? Yeah, so basically you'd be rotating it. Where would the axis be for that situation? The axis would be down here. Put a big dot right there. So our axis is right there. Now whenever you do torque problems, you have to have an axis, because why? Well, torque is equal to force times lever arm. This R here is called the lever arm, and the lever arm is defined as what? It's the perpendicular distance axis to force. Now looky. Is the force, so what's the force causing the torque here? The force that's causing the torque is the what? The tension. There's somebody pulling on the flagpole with a rope. Is the tension perpendicular to the flagpole? Nope. So we got to do a little bit of trig here. So let me show you how to do this. I want to clean this up and make this nice. So look, I'm going to erase. All of that. Okay, so the force pulling on the flagpole is this. We've got this tension like this, pointing down like that, that's equal to 500 newtons. And then this angle here, it's way not to scale, but it's 15 degrees. Okay, so we're using the torque equation. Torque equals force times lever arm. The key thing that you have to know is that force and distance must be perpendicular. So how do we make these perpendicular? Well, look, let me show you. I'm going to show you 2 ways to do it. There's 2 ways to do it. What you can do is you go, okay, the definition of lever arm, it's the perpendicular distance axis to force. Okay, so we'll extend that down. If you go from the axis over to the force, see how I extended tension like that? It's perpendicular, right? So this R, this distance right here, is the lever arm. See that? It's from the axis over to the force. It's perpendicular. Now, can we solve for this R? Yeah, because look, we got a triangle here. See this triangle? So how do you solve for a missing side with a right triangle if you have the angle? Using sine, cosine, and tangent. So let's look at sine. Sine of 15 degrees. So what's the definition of sine? Opposite. So what's opposite the 15? R. And then what's the hypotenuse?
Tension, which is 500 newtons.
No, not. It's the 25 meters.
Oh, it's 25 meters?
Mm-hmm. That's this right here. So see the right angles right here? So over here, that's the hypotenuse. Okay? So R is going to be sine 15 times 25 meters. And that comes out as 6.47 meters. Okay, so one way to find torque, you can go torque equals force, which is 500 newtons, times the perpendicular distance, which we just found out was 6.47 meters. So this gives a torque of 3,235. And then the worksheet rounded that to 40, 3,240. So that's one way to do the torque. So the key thing, the force and the distance have to be perpendicular. So we had to do a little bit of trig here. Okay? And by the way, before I show you the second way to find the torque, there's a second way you could have done it. Let's answer this second question. How could the person increase the torque without changing the tension? Increase the angle. If you came up to this flagpole and instead of pulling at a 15-degree angle, what if you exerted the tension like that? If you exerted the tension like that, well, what would be the lever arm? What would be the R for this? So that's perpendicular, right? What distance is perpendicular? So axis up to the force, it's perpendicular. What would be the lever arm for that? The 25. So basically, you could increase your lever arm by exerting the force, exerting this 500 Newton force perpendicular to the flagpole. Okay? Now real quick, let me show you the second way. Is everybody this copied? The second way we could have done this to find the torque. So let me so what we could have done, so we have the rope pulling like this. Tension equals, hold on, put on this side. Tension equals 500. That's this vector right here. This is 15 degrees. The flagpole's 25 meters high. The axis is down here. Okay, so let me get it, change color. We'll use red now. So look, what we can do is go like this. The tension has components. Did we do we did components in here, didn't we? No? Well, here's how you would do it. Look, the tension is pulling down and over simultaneously, right? The tension is pulling to the right, but it's also pulling down simultaneously. So if this is 15 degrees here, then this has to be 75 degrees. Now notice here, notice that this red arrow right here is perpendicular to the 25. You guys see that? This vector that I just circled right here is perpendicular to the flagpole. Can we solve for this guy right here? Yep, using trig. So we go cosine, so let's look at cosine. Cosine of 75. So now what's the definition of cosine?
That's the adjacent over hypotenuse.
Adjacent over hypotenuse. So the adjacent is what we're looking for. Not R, it's not the lever arm. It's let's call it Tx, right? The x component of T. So Tx over the hypotenuse. And the hypotenuse is 500, right? The hypotenuse is this guy. That's the hypotenuse, the 500 Newton. And then there's your right angle. Okay, so Tx will be cosine 75 times 500. So that comes out as 129.4. Now, look, so now we can solve for the torque. So torque is equal to force times lever arm. These guys have to be perpendicular. Well, check it out. Tx is perpendicular to the 25-meter flagpole. They're perpendicular to each other. So we go, all right, 129.4 newtons times the 25 meters. We made them perpendicular. And you get the exact same answer, 3,235 Newton meter. Oh, and the unit for torque is Newton times meter. In everyday life, outside of physics, you would say foot-pounds. Foot-pounds of torque. But in physics, you use Newton meter.